Well, I mean, you're the speaker. I should introduce you. Okay, so for our next talk, we have Rious, who actually put this year's badge together. Also known as Mr. Rapid Prototyper. How long did it take you to from the time you had the conversation with SkyDog till the time you had the prototype?
That was pretty quick. That was a couple of weeks, maybe.
Yeah. So he is entirely responsible for the badge and has really taught us quite a bit about programming and doing the hardware hacking. So he should be a very interesting talk.
Okay. So, to kind of set the stage for this, the theme I wanted, and talking to SkyDog, we'd kind of done this with the badges, was to have a badge that kind of anybody could use, something people get started with. And so I thought I'd kind of introduce this whole thing by, just kind of asking if your life's sort of like this. It's just boring. You live on a golf course. You sit at a desk. Nothing really happens. That's kind of how I feel. So I wanted to build something. And that's why I got started doing some of these microelectronics, because it's just fun. You can build things. You can use the programming and the tools you use for your job to do something that actually affects the real world. And so we'll get to how the badge is built, but we'll get to some rationale behind it first. We've been to cons like DEF CON, and Joe Grand, he did a good job with these. They're awesome. But one of the problems I always had with it is that, he'd pick something like the Freescale. Well, that's not easy to get working on every system. Try to do some Freescale development on your Mac. It's just, there's some barriers to entry, fairly substantial ones in many cases. Or, you've got like, my new favorite deal, I've got like 5 of these now, but you can get, some of these more advanced, more expensive microcontrollers. Same problem. It's like now you got to build out these tool chains, and there's work associated with getting stuff to happen with these. And I think that's kind of where where we took it from. We said, what's something simple that's out there that people are used to, that's got a community? And the Arduino was sort of the obvious pick. There's lots of stuff out there already for the Arduino. There's a community. They're not perfect, but they're inexpensive, and they work, and people can figure it out. So we kind of said, all right, how do we fit an Arduino into a badge? So we started out doing something that pretty much everybody can do. You could very easily breadboard your own Arduino, and that's what we did. We got the ATmega 328 chip, this little guy here, and we threw it down on a breadboard. We stuck the bootloader on it, and we had blinking lights. That's the original prototype of the badge. And in the background, you'll see that's the STK 500. That's a programmer for these guys, and retail, I think it's something like $80, so it's definitely not going to break the bank. Let's see. So when I got started doing this stuff, I started out with the 8051s. There was a company called Iguana Labs, and they made this programmer, and you could get this utility called PonyProg, and you could just do it. You get this little, kind of like the Arduino, only there was definitely more of a learning curve, and it was all assembly. And then, fast forward a decade, and we've got the Arduino, and everything's just on board. It just works. So if you wanted to replicate what we did and have some fun with an Arduino that you make yourself, I'm going to kind of fly through these, but basically, you can get a solderless breadboard. They're cheap, they're easy to use. Does anybody have a solderless breadboard? Okay. Does anybody have an Arduino? All right. So we're halfway there. And this is how I used to do everything. It was on the solderless breadboard, and then, so this is also a story of hope for you. Everything I did, it was all just hobby, like I'll do it on a solderless breadboard. This project, it was like, well, I guess I'll do something where I have to solder. So up until this point, I have 0 soldering experience. I've got like the playing around of microcontrollers. So the first one, it's this guy here. This was the first soldered together prototype badge. And let me tell you, if I can solder, you can solder. I like. And you'll see what I mean. If I can solder and that works, yeah, everybody can do it. There's no more excuses. Then we picked up this great utility board here. I'll plug these guys, the Evil Mad Scientist Labs. They make an awesome breadboard for the AT Mega series. And I think it's like $3 to buy this board. They break out all the pins that you need and give you a little bit of space to experiment on. So version 2 of the board, version 2 of the badge, made it onto one of these, and we made a few so people could play with them. Still in the realm of like, okay, I'm learning how to solder. This is going pretty well. I haven't started any fires. And now I was ready to make my own PC board. So I did what anyone would do, and I got on the internet and experimented with chemistry. So you've got, this whole thing just graduated as we went through, and so I got some hydrochloric acid, like 2 gallons of it at the Home Depot, and some hydrogen peroxide. This is like if you want to do it yourself, it's way cheaper than the Radio Shack version. So hydrochloric acid, hydrogen peroxide, mix it together. The internet has like some recipes or whatever, I don't know. It's just a little of this, a little of that. You'll get it. And then you throw your copper board in there, and you get your this was my first attempt at making the printed circuit board. And again, you can see that my soldering skills hadn't improved much by this point. But I got some sample chips from Texas Instruments, and decided I'd start out by trying one of those. Basically, this was like I did the toner transfer thing. You get a laser printer, print out your circuit board, whatever layout you want, and just iron it onto a piece of copper PC board, and don't get in the acid for a while. What was amazing was like it worked. It pretty much just worked. I had some advice along the way. People said make sure you use lots of flux. That turns out to be really good advice. So I put flux everywhere. It was like jelly everywhere. And went to town with a soldering iron, and I had my first, working chip on a breadboard, on PC board that I'd etched, and I felt like we were making some progress. So this is the first badge, do-it-yourself badge boards. And you can see we got the bus pirate hooked up and writing some code to the boards, checking them out. This is really, you can see from the picture it's not that much different than what we ended up with. And, to kind of put it into perspective, we're probably like at the 2-week mark from wouldn't it be cool if we had badges to, hey, look, we've learned how to make our own boards and do some surface mount soldering. And like I say, if this is something anybody could do. It's really that easy. I don't have as many before and after pictures as maybe I should, but trust me when I say you can do this. Get Eagle CAD or whatever and a laser printer. This is totally within your reach. So we've got the progression from our first few attempts at a board all the way to like sending off for these. And this actually, the legitimate circuit board layout, I would say out of all the steps in the process, turned out to be the most challenging because that's sort of where all the online support dropped off. All of a sudden I was going, okay, I can do this. Lots of people, there's a ton of tutorials for how to take, your Eagle file and print it out on your laser printer and iron it onto a board. And when it comes to using Eagle and convincing it that you want to make boards that somebody's going to do for you, it got a little different. So we slogged through that a little bit, and it turns out that there's this CAM processor, and I'll have some stuff on the blog about it, but basically there's a whole other section to Eagle with this CAM processor thing, and it eventually makes these Gerber files, and you send them off, and miraculously you get back stacks of these boards, and it is pretty awesome. Let's see, I got a picture of the stacks of boards. There. Stacks of these boards. And then it's time for you to do your job. So, the first thing we needed to do was a way to program them. You know, we had all these boards, and you'll notice I've got headers on mine, but you guys don't have headers on yours, although you should probably put some on. It'll make them a lot more useful. So we did the pogo pins. So we got these pogo pins. They're spring-loaded pins that don't photograph well. And but basically it lets you just press the board up against those pins and program them. So we've got this ISP header here, and so this is a pretty standard deal. You got this ISP header. It lets you write to the chip, and you can use, we're using the AVR Dragon there. That's the USB board with the wires coming off of it. You can use that. You can use the STK 500. There's probably 30 aftermarket ISP programmers for the AVR chips. You can use a bus pirate to do it. So chances are either you have something or you know somebody that's got some equipment that you can use. What we didn't want to do, though, is leave it so you could only program it with the ISP stuff. So we put the Arduino bootloader on here. And as we get near the end of the talk, we'll talk a little bit more about what you get from Arduino that's more than just the chip. But basically, we set up this programming jig, and there's lots of shots of us assembling these things. We did like the Henry Ford approach, and everybody kind of chipped in and did their piece. So we had like SkyDog soldering on these the chips themselves, and somebody else putting on batteries and buttons, and somebody else coming along and doing like the LEDs and the resistors. And slowly but surely, we assembled over 100 of these guys, all by hand. So it wasn't like, and all effectively with people that had never done any soldering before. So it's not just me that can do it. It's a whole bunch of people at the Hacker Consortium here. Even if you saw off the end of your finger, you can still participate. So I'll cover some of the easy tools. I'd say I've had a few people ask me, we've been talking at the Hacker Consortium about what it would take to get started. If you're going to buy one device, and I think I'm pretty split between just telling people to buy an Arduino because it just works and you can do stuff, and telling people to buy a bus pirate. I think it's a little bit of what you want out of it. If you just want something that's going to work right this second, the Arduino is great. If you think you're going to want to build things you're going to incorporate into projects, or you want to do a little more experimenting, the bus pirate's awesome. This guy's at Dangerous Prototypes. Put the design together, and you can use it to do in-system programming of quite a few different chips. You can use it to do, like in our case, we use it a lot as just a serial bridge. It'll do I2C and SPI serial and stuff that is just fun when you do it. You got the AVR Dragon. This is like a $50 board that you can buy right from Atmel, and it'll do in-system programming. It'll also do high-voltage programming. At some point when you're messing with these things, all the AVR chips have this concept of fuses. So you can program the fuses to tell it what clock source to use, or what section of memory to boot from. But when you're doing that, you can make some mistakes. When you make mistakes with your fuses, the chip is worthless to you at that point. If you have a high-voltage programmer, it's basically the only way to bring it back and set the fuses after you've jumped things up on yourself pretty good. We actually did that with the video feed stuff. We had a couple Arduinos, and the firmware had gotten junked up, so we had to bust out the high-voltage programming. You don't need much. I've got overkill for hardware. I mean, you need a soldering iron. The oscilloscope is just gratuitous, and a computer. So that's kind of that's the rah-rah, you can do it too sort of speech. And we'll back that up in the Hardware Village. If you guys have questions, we've got soldering irons and answers, and we'll try to help people get started. I threw in a couple of highlights of some of the things that you'll find in the code base. We'll post that later after some people have won the game. But maybe that's a good time to introduce some of the things on the badge. There's a game. If you attach serial headers here at the bottom and hook it up to an FTDI cable, there is a text adventure. And if you win the text adventure, your lights will go backwards. So you can identify the people who have one from the people who haven't. So hook it up. If you run into serious trouble in the game, you really get stuck, this button, the first button, will bring you back to the hotel lobby. So it also counts. It's one of the features, when we release the code especially, these guys have flash memory on board. So the ATmega 328s, they're just a 28-pin chip, and they've got 32K of storage. We put a bootloader on there, the Arduino bootloader, and so any Arduino sketches, if you have an FTDI cable, you can load Arduino sketches to it. It should be pretty easy to map out the pins, to the lights. You may have to do a little trial and error. Yeah. So TXRX is broken out, but it's TTL level, TTL voltage levels. So if you tried to hook it up to your computer serial port, it may work or it may blow up the chip. Yeah. Yes, you can, anything that you can get TTL level serial lines to, RX and TX are broken out here. And then you also have power and ground. Over here, so you can hook it up to FTDI or any way that you can get serial lines to it. And you can write to it just like you would in Arduino. We don't have the reset circuit on, so when you go to flash the chip, if you're doing it with the Arduino stuff, you'll have to hit the reset button, and it'll flash 4 times. As long as you get the boot process, as long as you get the code loading process in while it's blinking, then you'll be able to write software to it. The newer Arduinos, like these USB ones, they've got a reset circuit built in, so you don't have to do that. We also broke out the I2C pins over here. So we have 1 digital I/O and then the 2 I2C pins. And we also have power and ground. So if you want to play with stuff like real-time clocks or EEPROMs that are I2C, you can do that over here with these pins. On board these chips, the 328s, you've got flash space for the program, and you've also got some EEPROM space where you can store stuff. In this case, I store an incrementing count. I also store the game state, so as you're moving around in the game or collecting things, that gets saved to the EEPROM. So even if you pop the battery out, you don't lose your place in the game. We've got voltage level here. So it basically starts here at 3.2 volts and goes backwards in 1/5 of a volt increments. So 3.2, 3, 2.8, 2.6. You guys get the idea? So mine is it's between 2.4 and 2.6 volts are left on the battery right now. So as you're playing with it, you'll be able to monitor your progress. And we use some interesting stuff that the Arduino gives you. These, the ATmega 328 chips give you. They have an analog to digital converter. So they have an internal reference voltage, and they also have, so you can monitor external pins. You can monitor the external voltage. You can also monitor the temperature sensor on board. I think that's ADC8's, the temperature sensor. So when we wanted to figure out the voltage on the chip, we basically said, okay, let's set the reference voltage to be the external voltage, and we'll set the input channel to 1.1 volts. And we got a little bit of code here. Everything that we did for the badge is in C, but basically this is a quick rundown, a snapshot of some of the things that you can do with these without even adding external components. Just as easily as monitoring the voltage, you could go ahead and instead use the reference from the onboard temperature sensor and write some code to have it display the temperature of the chip in LEDs. Then the next button is a little game that we put on. It displays a random number. It's up to you to type the random number back in. And if you don't get the number right, it'll display what you entered, and then it'll display the number it asked for, and let you try again. So that'll be a fun game for people. When you get done, it'll read off some digits after you get it right, and you guys can figure out what to do with those numbers. Let's see. some of the other fun stuff that we did with these, we wanted to make sure that the battery would last for the entire con. And it's something, you know, having done everything just on breadboards up until this point, power management wasn't really an issue. It's like it's plugged into a wall wart. It's going to run forever. So it was fun to go through and learn about sleep states and some of these things. So I pulled out a few of the highlights from the data sheet. You can see that if we didn't do any sleep, you know, any power management, you'd get roughly 75 hours just on the chip. And then with the lights running, you'd get substantially less than that. So we've got it, every time it's not flashing lights, the whole chip and everything goes to sleep. So that's kind of that's the deal with the quick and dirty on the badge. So to recap, ISP, FTDI, here's some I2C headers. And then we can take some questions about the board. Or we had fun. We actually tried putting these together. We did it a variety of ways. So it's a good question. There's a variety of ways that you can successfully, like anyone can successfully do surface mount. With these are the LQFP, so just a low profile quad deals. And, you know, if you put down some flux and your soldering iron isn't too large, we had lots of luck just soldering the chips on by hand, you know, with an iron, with regular solder. The trick there, though, is flux. So when you're trying to do smaller components, the flux really helps with bridges in a big way. Then we switched over with these to kind of doing the drag soldering. So pretty much the entire time with the chips, we did them with an iron. With the larger components, we did those with an iron as well. We tried doing the hot air tool with the chips, and you know, we had some trouble with reliability. You know, just getting all the wires to bond, and then so anyway, the chip, I would say, you know, my limited experience at this point, but it's been that drag soldering or just pin by pin soldering with lots of flux works fine, even down to pitches like that. When we went, and with this, since it's all kind of lined up, you know, I would usually, like I'd tin one of the pads, I'd get one lead to sit down, and then after that, we just, you know, either drag solder or individually solder the pins. When it came to like the LEDs and the resistors, one of the issues we had was getting them to line up right. If you're doing them by hand, it's really easy to tip them one way or the other. So with those, we did the hot plate. We got some solder paste, and basically we already had the chips on, and we just rested the one end on the hot plate. And, you know, we would wait for it to come up to like 200 degrees Celsius roughly, and then we'd back the temperature off on the hot plate. So we had just an IR thermometer, and it was a manual process, but it worked. I'm sure there's more efficient ways to do it, but it was easy. I think really the only trouble we had is, I don't know, maybe 1 out of 5, 1 out of 10 boards would have a resistor that'd pop halfway through the process. So we'd have to, it wouldn't not explode, but it would just like stand up for no reason. So we'd have to fix that. And all these other larger components, you know, it's just big soldering iron, lots of heat, get it done fast. Yeah. So that's the best part of the speech, right? So we learned a lot while we were doing these, for sure. One of the things that we did, we worked quickly to get the prototype piece done, and I think, so the idea was like, we were like, oh man, we're rock stars. We got the prototype done. We got these things working. The production stuff, that'll be easy. I think we would have ordered the stuff sooner. We were doing these up until like yesterday. So there's like, I think we underestimated the amount of man hours to assemble them. That's one thing we would have done. The other thing is that we never had a reference. I mean, like we made some by hand, and then we made a few changes to the board, and we sent out and bought like 200 of these boards. We hadn't done that before, so that was it's not that it worked out fine. It's just I didn't sleep for a week while we waited for them to come in, because I kept thinking, man, we spent a lot of money on something that might not work at all. So I would have, I think going into the future, I would have ordered a few ahead of time, tried them out, and slept better when we spent $500 or whatever it was to get the batch of them in. Then when we did get them in, I forgot how to use Google. So we got these chips in, and we got the boards, and we put, I think, SkyDog and I sat down, and we put maybe like 4 of these together. And we get them together, so we got all the money into the equipment and the boards and, all the pieces. And we put like 4 of them together, and, we're dinking around, and I get the bootloader flash to one of them, and I get, when they come, they're all clocked slower. So we went in and set the fuses so that they're, now they're running at 8 megahertz. And, we set them up so that they'd boot out of the bootloader sector, and we loaded this bootloader code to them. So I got one of them to work, and it's going fine, and we felt really good, and then the other 3 didn't work at all. Like, I'd hook them up to I'd hook them up to my Dragon, and it would say, like, it'd come back, it always reads the device signature off of them, and it'd come back, device signature is all zeros. There's something wrong. And so we spent like an entire day trying to resolder everything, starting to worry. And I think the most frustrating piece is that we had one that worked. So we're like, it can't be totally broken. And we burned so much time, and then, and I don't know what happened, but at some point I finally decided I should probably Google for this device signature is all zeros. And I did. And it was like, oh, you're trying to write to them too quickly. Just add this command line flag when you try to write to them, and everything will be fine. So that was, I'd forgotten how to Google, and it turns out that's really, honestly, all it was, is when they'll come from the factory slower, like, so they're slowed down, and the AVR Dragon tries to write to them too quickly, they don't respond. So I would say, this is kind of advice for life, though. I use it at work all the time. It's that, usually your design is right, and oftentimes your code is right, and usually it's like it's a typo or something. You just sort of, it's usually the simple stuff. So we fixed these up. In the process, I think I would have also rebuilt this jig over here. Well, this is us doing the solder paste deal. We were talking about things we would have done differently. This is one thing I would have absolutely kept. This making these stencils. We tried it out a couple different ways. We ended up using vinyl from the vinyl cutter, throwing it in the laser and cutting out the stencil. And that was actually more successful for us than the Kapton tape. So it's cheap. It's way cheaper than Kapton. And, we'd probably get like 30 boards or something before we'd have to cut a new stencil. It isn't that many, but that vinyl is so ridiculously cheap that it was nothing to cut out a bunch of these stencils.
So you put that on, and then you had holes cut, then you run the solder paste over that, and you did like the solder paste onto there, and
Yeah, so it's a lot like screen printing, and almost identical to it. We had some solder paste. We got it from Chip Quick, and we just we squirt it onto that badge that he's holding in his right hand or his left hand, and smear it across just like if you're screen printing. The vinyl was thick enough; it would leave just enough of that the solder paste, and then the solder paste is kind of thick and heavy. So once you set these components down on it, they're tacked in place, and they're tacked in place well enough that we could pick up a handful of the boards and carry them over and do it on the reflow plate. So we learned that. I probably wouldn't have finished up the final version of the code from my hotel room last night. I got the flu like about a week before this thing was going to happen, which was like my week to be working on it. So I was at a hotel room last night, like getting the final version of the code done, and emailed it to these guys, and they flashed it all, thankfully. But this is our pogo pin jig, and it's basically a few pieces of acrylic. We took some advice from Lady Ada and did some things right with it, so we used one of these boards, and we stuck the pogo pins through the actual board. And she's got some cool pictures about it on her site using the pogo pins. So they were great. But what I would do next time, I think, is leave space in my design to accommodate that, or actually order a jig board. The pogo pins, they're not so hard to solder into the board, but because they conduct heat so well, they're all gold-plated. They were really hard to solder wires to, after they're already in the board. So we had trouble like keeping the pogo pin stable in the board and then actually attaching wires to them. So I would either make produce a specially made board for it, or make sure that like I had a way to get it the pins I wanted to pogo pin some other direction. Even if it was just having some extra vias that I could solder wires to. I think we would have spent a little bit more time on the programming jig because, it took about 30 seconds a pop per badge, and that pretty much meant like you hold it down, hit go on the computer, and don't move for 30 seconds, and then. So the pogo pins are great, but I think we could have improved that. I also think for next year, this year I think it's this year we wanted to do something that was easy, that use something like the Arduino deal. Everybody can download. You can download Arduino for the Mac, for Linux, for your PC, and you can write to it. We've got the bootloader on here for you. Next year I might up the ante a little bit. Maybe we'll choose a different architecture. I mean, there's a lot of options out there right now. You've got, I don't know, has anybody picked up an MSP 430? Yeah. These guys are great and they're cheap. And TI will send you a crap load of samples of anything you want. One of the nice things about this too is that they actually give you the real programmer on this board. So $4.30, and TI will send you, a development board that's got pins broken out on it, that comes with 2 chips so you can swap them out, and comes with a programmer debugger interface. I mean, you can't really beat that. But there's not as much of a user community. It's growing, but it's a little more difficult. It's not like install Arduino. It's like, go and install this and kind of tweak it and get it to work. But next year we might go that route. I think there'll be some fun stuff with that. There's some other options out there too if you're doing things. This is sort of the generic hardware hacking speech for a second, but I would absolutely encourage people. These companies send out samples. ST Micro has been really generous lately doing these STM32F4 discovery boards. Like, they'll send this to you for free. You can't really beat that either. In the same way, like with TI, it comes with some crappy chips, but they'll send you samples of lots of good chips as long as you can mount them to a board. So if you've got a soldering iron and $4 worth of board from Radio Shack, you can get these $15 and $16 chips. They'll mail you a pair of them for free, and start to have fun with things. So, what I learned from this whole process is that you can solder, you can make your own boards, and it's not nearly as intimidating as I thought it was going to be. And we'll give some demonstrations later on over in the hardware hacking area. Are there any other questions? Oh, it's first year, no way. I do have to. There are some people that were kind of inspirational. There's Goodspeed that did the HopeCon badge. He's got some pretty awesome stuff, and he's big with, he's been big into the MSP 430s, and so, I really like what he's doing with the MSP 430s and followed a lot of that. Obviously, got Joe Grand with some of these with the DEF CON badges. We figured we have a slightly different audience, and we wanted to give people something, to kind of encourage people, hey, you can do this, you can have some fun with it. Hopefully that way next year when everybody shows up again and we've got a badge that's a little more sophisticated, we'll have a little bit of fun with that and up the ante on you. Anybody else? All right. Well, thank you. I am.